Marimar is made easy, no more fear. Toydale online class, we got you. Wherever you want it from, we got what you need. Toydale online class.
Good day, viewers all over the world. You are welcome to Toydale online class. Today we want to look at another application of integral calculus, integration. I want to talk about volume of solid of revolution. Volume of solid of revolution. We've actually talked about the area. So in this case, there are two things that we consider. The volume generated when the curve y is equal to f of x is revolved about the x-axis. When that curve is revolved about the x-axis through 2 pi radians, that is 2 pi radian is a complete circle. 2 pi radian is a complete circle when we have something of this nature. Now this is 180, this is another 180, and that 2 pi is 360 degrees. The volume generated when the curve y is equal to f of x is revolved about the x-axis through 2 pi radians is called volume of solid of revolution. It's called volume of solid of revolution, and it's given by, when we have the volume along the x-axis, when y is equal to f of x, we are going to have it to be integral from a to b pi y squared the x. That's what we are going to have. Then where we have this lower and upper, the boundary, this bound, where a and b are the ordinate, that is the value of y. Ordinate simply means the value of y. But the second case is the volume generated when x is a function of y now. In this first case, y is the function of x. We have ordinates. When we now have x as a function of y, we are going to have abscissa. Abscissa is talking about the values of x, the values of x along the x-axis. So the volume generated when x is a function of y is revolved about the y-axis. That's when it's revolved about the y-axis through the 2 pi radians is given by, in this case now we have v to be equal to pi s squared dy. So we have dy here, we have dx here. So when we have y squared, we talk about the value of the bound a and b to be the ordinates. When we now have CD actually represents the abscissa, talking about the value of x-axis. So let's take note that the volume of solid of revolution is given by that formula. Now, depending on either what you are given is abscissa or ordinate, maybe the volume is along the x-axis or along the y-axis. So we are going to take example on each of the two conditions. So let's take the first example. Example one. Let's take the first example. Example 1. So in that example, we are to find the volume. We have to find the volume of the solid of revolution generated when the region bounded by the curve x is equal to 3y squared. The ordinate is talking about the value of, when we talk about ordinate, is along the y-axis. The ordinate x is equal to 2 and x is equal to 2 and x is equal to 5, and the x-axis is revolved about the axis through 360 degrees. And of course, we know that 360 degrees is 2 pi in radian, 2 pi radian. That's the same thing as 360 degrees. So we are on the safer side. Let's look at the question very well. We have to find the volume of solid of revolution generated when the region bounded by this curve x is equal to 3y squared. The ordinate, in this case now we are given the ordinate. And from our earlier explanation, we said when we are given when the thing is revolved, the curve is revolved about the x-axis through 2 pi radian, then the volume is given in form of v. V will be equal to pi y squared dx, and a and b will be the ordinate. So we are given the value of a and b here as x is equal to 2 and x is equal to 5. So we are going to rewrite what we are given in form of y. We rewrite it in form of y squared. So we say solution. So what is the curve? X is equal to 3y squared. So and we know that the volume, when it revolves along the x-axis, is given as integral a to b pi y squared dx. That's what we are going to have when we have it at the ordinate. When we are given the ordinate, this is what we have. But when we are given the abscissa, then we are going to have volume to equal to integral c to d pi squared dy. That's what we are going to have. So I'm going to rewrite this now and make y squared the formula. If I divide both sides by 3, this will cancel this. Then y squared will be equal to what? X all over 3. That's what I'm going to have here. Then what is the value of a? A is x when x is equal to 2, and b is when x is equal to 1. So we say a is equal to 2, and b is equal to 5. So what will be the volume? The volume of the solid by formula will now be integral from 2 to 5 pi y squared is given as x all over 3 dx. That's what we are going to have. Then we can bring out pi all over 3 to have integral 2 to 5 x dx. So we can actually integrate integral of x dx. So if we integrate the integral of x dx, we are going to have, so here we are going to have pi all over 3. When we integrate x, we are going to have x squared all over 2 from 2 to 5. That's what we are going to have. Then in this case, we are going to have pi all over 3. We substitute when x is equal to 5. 5 squared all over 2 minus 2 squared all over 2. That's what we are going to have there. That is what we are going to have there. So from there, we are going to have it to be pi all over 3 into bracket 25 all over 2 minus 4 all over 2. And of course, when we subtract that, we are going to have pi all over 3 multiplied by 21 all over 2. That is what we are going to get. If you do that correctly, that is what we are going to get. And at the end of the day, we are going to have 21 all over 6 pi, which is same thing as 3.5 pi units cube. That is what we are going to have. So that volume, or unit cube, or we say cube units, is still the same thing. So the volume that we have to find, the volume of the solid of revolution generated when the region bounded by the curve, this, and the ordinate is this, is given as 3.5 pi cube units or unit cube, is still the same thing. That's what we're going to have, and that will be the answer. Then we go to the second example. Let's take another example. In this second example, in this case now, we have to find the volume generated. Okay, let me write the question. So in this case now, we are given the ordinates. We use the formula V is equal to integral a to now let's use an example where we have the region enclosed by part of the curve y is equal to 4x squared. The lines y is equal to 1 and y is equal to 3, and the y-axis is rotated about the y-axis through a complete revolution. A complete revolution is 360 or 2 pi in radian. So find the volume, the solid, find the volume of the solid revolution generated. So that's what we are asked to find. I want us to compare this example now. In the first example, it's true. We are given the value of x being 2 and 5. So we talk about ordinate there. Here now, the question says that the region enclosed by part of the curve y is equal to 4x squared, comma, the lines y is equal to 1 and y is equal to 3, and the y-axis. When we are along the y-axis, we talk about abscissa, that is the value of x. When we are along the x-axis, we talk about ordinates. We are going to talk about ordinates, and that's the major difference. So in this case now, the volume that we have to find by formula is given us from speed